Hi guys, this is a calculus video 5-15, and this one is also to be watched before Monday, January 30th. There's going to be no homework that corresponds to this. And here we're just doing like a little summary of U substitution. And we're going to take the antiderivative here of a very complicated function. And notice that there are three terms. There's, so we've got this first term here, and then plus we've got this second term here minus this third term there. And the way the antiderivatives work, and integrals will work the same way, is you can split it up. So taking the antiderivative of a sum is the same as the sum of the antiderivatives of each term. Okay, so what I'm going to do is this. I'm going to use is this additivity? I don't know if it's the additivity rule. I think this is maybe the sum or difference rule. So I'm going to use the sum rule for antiderivatives, and I'm also going to use the constant multiple rule at the same time. And I'm just going to rewrite it like this. I'll rewrite it as 6, because I can bring out a constant multiple. So 6 times the antiderivative of, and I'm also going to do this, guys, anytime you're taking a derivative or an antiderivative and you've got a trig function raised to a power, rewrite it like this. Okay, because if you're taking the derivative, it'll be easy to see that you need the chain rule. But if you're taking the antiderivative, it'll be easy to see that you need U substitution. And a good U to choose is always an inside function, a function that's inside of another. Okay, and then times sine of x dx. Okay, so that dx basically is saying that I'm stopping this antiderivative. Okay, then I bring down the plus sign, antiderivative of x squared over x to the third plus 2 dx minus, I'm going to bring out, so this is like a coefficient of 1/2. You could rewrite this as 1/2 times 1 over x to the 7th. So I'm going to bring out 1/2 antiderivative of, guys, I already know that I can't apply the power rule unless this is of the form ax to the n. Okay, so I'm going to rewrite it as x to the negative 7. The same way you would as if you were taking a derivative. Okay, so then I have to ask myself, what do I have to use for each of these parts? And another reason why it's so important to split up this antiderivative is because the same rule is not going to apply to each term. Okay, for this first term, we have definitely can't use the power rule, not of the form ax to the n. Definitely don't have a formula for the antiderivative of this function. And also, I should point out, you cannot split up an antiderivative over multiplication. So I've got to try U substitution. I have no other choice. And the hardest part for people when they're learning U substitution is, what do you let U equal? Well, guys, I would say 99% of the time, the U is going to be a function that's inside of another. I see that I have cosine of x inside of blank to the third. Okay, so I will let U equal cosine of x. And then you find the differential of this. So du, that's the differential, is equal to negative sine of x dx. Then you solve for dx. So dx equals 1 over, I'm dividing both sides by negative sine x, negative sine of x du. Okay. Now I'm going to move along, but so I'm all ready to do substitution for this, okay, when I want to do it. Now this next one, when you've got a quotient, when you're taking the antiderivative of a quotient, you ask yourself, is this of the form f prime of x over f of x? So you let f of x equal the denominator. Then you take its derivative, and if you're only off by a coefficient, so I could use the formula that we did in the last video if this numerator were 3x squared, but it's not, it's only x squared. So if you're only off by a coefficient, i.e. a constant multiple, you could just go like this. I could just put a 3 coefficient of a 3 there. That's like multiplying the whole thing by 3 over 1. But if I multiply by 3 over 1, I also have to multiply by 1 over 3, but I'll do that on the outside because those would cancel each other out, you know. So I basically haven't even changed the value of that because I basically multiply by 1. And then I'm going to be able to use this. Okay. And then this one is just going to be a straight power rule when I'm ready to do it. Okay, so I'm going to move to the next line. And, okay, so I'll do the u substitution here. So this is 6, antiderivative of. So cosine of x, that's what I let be u to the third, times sine of x, times, now I'm plugging this in for dx. Okay, so this is going where dx used to be. So I'm putting 1 over negative sine of x du. Okay, you will know that the u substitution is going to work if all of the x's cancel, if everything having an x cancels, and it is happening. Okay, so I know that I've chose a good u. So you want, when you do u substitution, everything has to be rewritten in terms of u. Okay, so there's that. All right, now I'm just going to keep going. So the next line, I'm going to bring everything down. Okay, so this is, oh, I'm going to bring that negative outside. So this is negative 6, antiderivative of u to the third du. Now I'll bring this, I'll just do this antiderivative now. Okay, so this is going to be plus, I'm all set to do this antiderivative. So this will be plus, I'll carry down the third, and then I'll use that formula that we had yesterday. This is the natural log of the absolute value of the function in the denominator. Notice, I'm not doing a plus c after all of these. It's enough to just have a big plus c at the end, because c can be any constant. So we could just put it at the end. All right, so there's that. And then this last one, I'll carry down the negative 1/2, that's the constant multiple rule. And this one I could just use power rule on. So this is x to the negative 7 plus 1 is negative 6, and then I have to divide by negative 6, which is the same as multiplying by 1 over negative 6, and then plus c at the end. Okay. Now this one, I have not taken the antiderivative yet. As long as this integral, empty integral sign is there, you have not taken the antiderivative yet. Well, if you had taken the antiderivative, it should go away. So I'm carrying down the negative 6. That's the constant multiple rule. U to the 4th over 4. Okay? And I'll just, how did I do this? I won't bring down the rest yet. Okay, so this is just like an intermediate step here. Okay, so I'll bring this down simplified. I'm going to have negative 6 over 4. So that'll be negative 3/2, which is coming down. And then u to the 4th, but I have to plug the u back in, and u was cosine of x to the 4th. Okay, plus a third natural log, absolute value of x to the third plus 2. And then this is minus 1/2, but then this is also times negative 1 over 6. Okay, so this is, imagine that you had a negative 1 over 6 out in front like that. So this will be plus 1 over 12 x to the negative 6 plus c. And if you want to rewrite this as cosine to the 4th of x, you could do that. So there's that, guys. That's about as complicated as u substitution can get. And there it is. Okay, I will see you soon. Bye-bye.